Okay, let's talk about what is root mean square value or RMS value. Now the problem with AC, which is sinusoidal AC specifically, is that the voltage and the current will vary continuously. Remember, right? So if you wanted to use just one value to represent the sinusoidal AC, what value would you choose to represent the AC? For those who suggested using average, it wouldn't work because the average will be 0 because it fluctuates from positive maximum to negative maximum. Then people say use the peak, but peak is also not accurate because it's only at that point for a very short time. So they came up with a term called root mean square value. So what is actually the root mean square value of an AC? So what they did was they compare an AC with a DC. For example, okay, let's say you have this resistor here that you connect to a alternating voltage, and then your same resistor you connect to a direct voltage. So the RMS value for the voltage that you use here is equivalent to the same value of DC that you would use to produce the same power in both. For example, right, let's say to get an average power of 5 watt here and to get the same average power of 5 watt here, then we look at the voltage that you use in your DC. So the voltage that you use, let's say, is 2 volts. So 2 volts DC produces 5 watt in your resistor, average power of 5 watt, and it also produces 5 watt in your AC. So which means to say the voltage that we are using here, the RMS value is called 2 volts. But of course the peak value is definitely not 2 volts. But the idea behind the RMS voltage is it is the equivalent value of the steady direct voltage. It means it's the equivalent value of the voltage that you use here that will produce the same average power in your resistor as your AC in a given resistance. So what you just have to do is find the equivalent value of the direct voltage that gives you the same average power. Now this is a very useful term, RMS, because it allows you to convert from AC to DC without having to do much work. For example, let's say our house, we are always using AC, right? We are using 240 volts AC. And because they use 240 volts, it must refer to RMS, because the standard way of labeling an AC, if you are using just a single voltage, it automatically means the RMS voltage. This is used worldwide. Okay, so which means to say, if let's say there's a power failure in your house and you wanted to operate your, let's say your iron, that you want to iron your clothes, so you know the setting that you use all the time to give you the best results for your clothes, not too hot, not too cold, right? But then once there's a power failure but you really need to, let's say, iron your clothes, so how many volts should you connect to your iron? Because you can buy batteries from the shop, or we call it cells, and then how many must you connect to give you the same average power as the one you are used to? So because the RMS voltage is 240 volts, you can actually connect all the cells or the batteries together, whatever you call it, in series so that you can get 240 volts. And if you do that, you will get the same average power as your AC. So that's why your RMS value is defined as this. So you can define the root mean square value of either the current or the voltage, depends on what they want, as the equivalent value of the steady direct current or voltage, which would dissipate heat at the same average rate, that means the same power, as the AC in a given resistance. Alright, so I just taught you how to convert. You want to convert AC to DC? If you know the RMS, you just substitute the direct voltage with that value, you'll get the same average power. Same thing goes for current. If you know the direct current value that would give you, if you want to find out direct current value to give you the same average power, you find the RMS current of your AC. So what is the formula? The good news is you don't have to know how to derive it, although it is in your notes. If you want to, you can refer, but it's not compulsory to derive it. So how they derived it was they actually equated the power here in your AC to your power here in the DC, and then they managed to find out that the voltage Vrms is actually equals to V0 over root 2, which means to say you take the peak voltage of your AC and you divide by root 2, you'll get the RMS. And therefore the IRMS, which is the root mean square current, is also I0 over root 2. So it's quite simple, the calculation. You just take the peak divided by root 2, that's the RMS. But you can also move the other way. That means if you're given the RMS, you can find the peak. So you take RMS times root 2, you get the peak. For example, now when we say that in our house we use 240 volts, which is RMS, let's find out what is the highest voltage that you can get in your live wire. Because how electricity is transmitted into your house is something like this. I give you just a diagram. Let's say this is your house. So there will be an electricity pole coming from the power company, like in our case will be DNB, Tenaga National. So they will give you a live wire. Alright, they'll connect a live wire to you. Alright, and then your in your house here, you also have a neutral. So you have a neutral wire that goes down to the earth. So what will happen is, your live wire is the one they will give you the sinusoidal AC. Okay, so what will happen is, when the voltage from the TNB is positive, then current will flow from live into your whatever electrical appliance. Then you come out through your neutral, because your neutral is 0, so it's lower than your positive voltage. So current will flow from higher to lower voltage. But if let's say the voltage from the live drops to negative here, then the potential at your neutral is higher than the live, then the current will flow from your neutral to your live. That's why you get alternating current. Okay, now, so these two is where you connect your appliance to. So you know your wall plugs and all that, wall outlets. So your wall outlet, you will have one connecting to neutral, one connecting to live. So that way you can plug in anything, so the current will flow through the live, through your appliance, and come out through a neutral. Or come in from a neutral, go into your appliance, and then come out through the live. So what is the maximum voltage that we are having at the live wire? Because the neutral is always 0, so the live is the one that fluctuates. So if your RMS voltage in our house is 240 volts, then the maximum voltage in the live will be 240 times root 2, which will give us 339.4 volts. So in other words, the highest voltage in your live wire is not 240, it's actually 339.4 volts. So that's how you can actually move from RMS to peak. So you can also move from peak to RMS. If you take this root 2, you also get 240. So let's talk about the advantages and disadvantages of AC. Now, the advantages of AC is that you can use a transformer to step up and step down the voltages easily. See, transformers are very useful and it is very easy to step up, step down voltages if you use a transformer. But it can only work on AC, because when you learn in EM induction, you have learned that you need a changing flux in your secondary coil in order to induce an EMF, which is why you need an alternating current coming from the primary coil. Then only the flux will keep changing. So you need an AC to run your transformer, and the transformer can step up and step down the voltages easily. So why do they want to step up the voltage? Okay, we will learn that in the next part. But we usually just tell you I just tell you briefly what they do. When they step up the voltage, it is during the transmission over large distances, so that the current in your cable is small, so you have less power loss as heat in your cables. But just before the consumer uses it, they will step down the voltage, so that in case you accidentally touch the live wire, the danger of a large current passing through you is not great. So there will be a small current passing through, so you will not die immediately. Right? So that is why they need to step up and step down the voltage. So that is the advantage. The disadvantage of an AC is that it will need a thicker insulation, because you see, if you are using an AC, your live wire reaches 339.4 volts, so you need to insulate your wire against 339.4 volts. If you're using DC, you only need to use 240 volts DC to produce the same average power, and you don't need such a thick insulation, because highest voltage is just 240 volts. Alright, then there's another disadvantage of AC. Some appliances or some electronic components may need DC because they cannot work on AC, so then you will have to have extra circuitry to produce rectification, which is to convert your AC to DC. Alright, because not every electrical component or electrical appliance can run on AC. Example, your handphone charger. If your handphone charger runs on AC, then you will never get charged, because it will charge, discharge, because it flows both ways. So then you got to convert to DC. Some electronic components in your TV as well, they have to convert into DC. So you have extra circuitry there. Alright? Alright. So don't forget, stepping down the voltage and stepping up the voltage, not only is just to, like, stepping up is not just to reduce power loss. Stepping down is not just to for safety, because some appliances or some electric components need different voltages to run, and it's easy if you use an AC. So you can just switch between any voltage that you want easily using a transformer. Alright, that's why AC is still used in the whole world. Nobody produces DC. And if you think about how a generator works, right? How the turbine rotates and cuts through the flux, you'll notice that it automatically generates AC. So you don't have to purposely try to generate AC. You just have to rotate the coil between two magnets. It will automatically generate AC because of Lenz's law. So the next thing I want to tell you is, why is the name called root mean square voltage or root mean square current? Because the name doesn't seem to relate to how we interpret the meaning of RMS, right? Not equivalent value, to get average power. Now, why they call it root mean square? Now, in deriving the formula, they actually they actually compared the power in both of them, and then they got the equation. But they quickly realized that there's another way to get this equation mathematically, which is to find the root of the mean of the square of the voltage or current. Then you get the same formula. Example, now imagine if I were to plot this graph of V versus T, for example, it will be sinusoidal right now. So forget about the sine omega T, and the 1 and negative 1. So this will be your V naught, this will be a negative V naught right now. So when you want to find the root mean square, that means you find the root of the mean of the square. So if I were to square this graph, the V naught will become V naught squared. The negative V naught will also become V naught squared. So in other words, what you will get is you get V naught squared like this. Alright? And this will be V naught squared over 2. Okay? So forget about the 1 and the half. This is a new value. So root mean square. So after you find the square, you find the mean. So what is the average value for this graph? Since the highest is V naught squared, the lowest is 0, so the average will be V naught squared over 2. So it's root mean square, so the next step is to root it. So you root this, what do you get? V naught over root 2. So do you realize by finding the root of the mean of the square of this graph, you also end up with the same formula. That's why they call it root mean square. But of course, they didn't use this method originally. They used comparison of power to get this. And then they realized that there's another way to get this formula, which is finding the root of the mean of the square, which is why they call it root mean square voltage or root mean square current. Right, what about for square waves? Now, what about root mean square voltages or root mean square current for symmetrical square waves? So this is talking about symmetrical square waves. How we usually can get symmetrical square wave is that let's say you got a DC supply, but then halfway you change the polarity, halfway you change the polarity, halfway you change the polarity, then you get square wave. Then we're changing DC to AC, then you get this. So how to find the root mean square value? So again, we use the maths concept, find the root of the mean of the square. So if this is the I versus T, let's find the square first. If I square I naught, I get I naught squared. If I square negative I naught, I also get I naught squared. So in other words, I will just get a consistent value of I naught squared. So after we find the square, what should we do? So remember, it's root mean square, so you find the mean. So what's the average of this value? Many people thought it's half, but it's not, because it doesn't vary from 0 to I naught squared. It's just I naught squared throughout. So therefore, the mean is also I naught squared. Example, if you are 5 people, all of 60 kg, the average is still 60, not 30. Unless you got 2 people, 160, 10, then the average is 30. You understand? So therefore, the mean is still I naught squared. And the final step in the root mean square is to find the root. So you root the I naught squared, you also get I naught. So for symmetrical square waves, the RMS value is equals to the peak value. Very important. So only for sinusoidal waves or sinusoidal AC, then only you will say that the IRMS is I naught over root 2, or V RMS is V naught over root 2. For symmetrical square wave, peak value is equal to RMS value.